So today we're going to finish up chapter 10. We're going to cover section 7, and we're going to talk about circles that are graphed in the coordinate plane. We're going to learn the standard form of the equation for a circle. Now, you're also going to do this in Algebra 2, whether you take Algebra 2 regular or Algebra 2 honors. You will also cover circles again in Algebra 2. You're going to do a whole chapter on conics, and the conics are parabolas, circles, ellipses, and hyperbolas. So here, our first slide is talking about when the circle has the center at the origin, at the order pair 0, 0. And then what we'll do is we'll look for the radius length. And then all we need to do is once we realize our circle has a center at 0, 0, the equation will always be the same. It's going to be x squared plus y squared. And then whatever the value of the radius is, whatever that length is, will go right here and you're going to square it. So for example, they're either going to give you a picture and then you'll confirm that the center is at 0, 0, or they're going to write it in words. So for example, if I told you that the center is at 0, 0, and it has a radius length of 3, and if I say write the standard form of the equation, all you're going to do is take the standard form, x squared plus y squared equals r squared, and all we need to do is replace the r. Put in the 3 and square it. So it'll become x squared plus y squared equals 3 squared, and then you actually have to do it, and then the final answer here would be x squared plus y squared equals 9. So here's another example, and it wants us to write the equation of the circle that is shown. So the first thing we need to do is confirm where the center of the circle is located. So if I look at my picture here, I can see that the center of my circle is right here at the origin. It's at 0, 0. Notice in each one of my little squares here, each little square is 2. So this would be a 1, this would be 2, 3, 4, and then this one's labeled 5. To figure out the length of the radius, I can count the squares of the horizontal segment for the radius. So this would be a radius. Notice it goes up to 5. I could also count the squares vertically, and I could count up this way and see that this also has a radius length of 5. Remember, no matter where the radii is drawn in your circle, it's always going to be the same length. Now, if you drew a radii that was diagonal, let's say you drew it here, then you would either need to do Pythagorean theorem or the distance formula. And you would be given a point that is on the circle to do that. But again, if it's graphed, look for the radius that's drawn horizontally or vertically. So now that I found the radius length, and I also confirmed that my center was at the origin, I can go ahead and fill it into my standard form. So this has, again, the center at 0, 0 with a radius length of 5. So I'm going to plug it into x squared plus y squared equals r squared. X squared and y squared stay the same. My r is 5. I need to square it, and the final answer is x squared plus y squared equals 25. So now we have 3 examples. Again, it wants us to write the equation of the circle given a center and a radius. So again, remember the radius, this is going to be the letter r in our formula. And again, all I need to do for part A is I'm going to do x squared plus y squared equals r squared, which is 4. And then I'm going to square it. And my equation is x squared plus y squared equals 16. Now here again, just like in the homework last night, we're going to be squaring this square root of 5, which is going to make the radical disappear. So for example, on part B, again, the radius here is the square root of 5. So again, I'm going to plug it in. X squared plus y squared equals the square root of 5. squared. When you square a radical, it just disappears. So the standard form for example 2b is x squared plus y squared equals 5. And then the last one, same thing. We're going to plug it in. X squared plus y squared equals 4 square root 3 squared. Now, when we square that, when it's also got a number outside the radical, if it helps you to write it 2 times, because that's what squaring means, I multiply outside numbers together. So 4 times 4 is 16. And again, when you multiply a radical by itself, when you square it, the radical disappears, and then I'm left with 48. So now I just have x squared plus y squared equals 48. Now, the standard form of the equation when the center is not at 0, 0 is going to be this one down here. The x squared, the x minus h squared plus y minus k squared equals r squared. This formula that's right here, this is going to be the formula used to find the radius. But if you notice, it's just the standard form with a radical on top of it, because all they really did was take the standard form and solve it for r. So now what's going to happen is you're going to be given an order pair. The order pair for the center is going to be represented by the variables h and k. For those of you who remember back to your Algebra 1 days when you did parabolas, the vertex of a parabola is also represented by the variables h and k. So this time it's also applied to circles. So again, in my picture here, this is the center point, the h and the k, and then the x and the y is just going to be a point that is on the circle. Technically, you could just use this formula. Even when the center is at the origin, you're just plugging in a 0, which then makes it become an x squared, because x minus 0 is just x, and then you square it. So let's try some examples. The 3 examples here have the exact same radius length when we did it with the center at the origin. So again, the formula we're using here to find the standard form is x minus h squared plus y minus k squared equals r squared. Again, the center point, all of these centers here, this is the order pair hk. Now, notice in the standard form that you're memorizing, this is subtraction sign is part of the formula. So when you go to plug in a negative number, that negative coordinate, h or k, is going to turn into a plus sign. And we're going to see it when we do example B. So let's try the first one. Part A, given the center is 1, 2. Again, remember this is h, this is k, and then we're going to plug in also the radius, which is 4. So I'm going to put the radius right there, the r. H goes here, k goes here. So we're going to fill it in. So it'll be x minus my h, which is 1. Okay, so then now I need to put squared on the outside of the parentheses plus y minus 2 squared equals 4 squared. So then now all I have to do is simplify the 4 squared. So the final answer is x minus 1 squared plus y minus 2 squared equals 16. Now, just to show you that the exact same question that I just did when the center was at 0, 0, with the same radius, what I would have plugged in if you wanted to just memorize this equation here, you would have done x minus 0 squared plus y minus 0 squared equals 4 squared. And then x minus 0 is just x. And that's how it turns into this. So if you prefer just to memorize this one equation, and then just remember if the center is 0, 0, eventually it will just simplify to an x squared, y squared. Pretty good? Let's try example B. Now this one's got a negative h, so we have to be careful. So for example B, the center is the order pair negative 3, 5. And again, this is h, this is k, and then the radius is the square root of 5. So let's plug it in. So x minus, and then you're putting a negative 3 here. So what we're going to do is simplify that negative negative and make it x plus 3. And then let's fill in the y, plus y minus, and then the k is 5. And then I'll put in my r squared. And then now let's rewrite everything else. Plus y minus 5, square that square root of 5, and it just turns into a positive 5. So again, whenever your h or your k is negative, that negative negative will turn into a plus sign. Let's try part C. Center, order pair 0, comma, negative 2, with a radius length of 4 radical 3. So that's where I'll put blue, red, and we'll fill it in. So x minus 0 squared plus y minus negative 2 squared equals 4 square root 3 squared. So again, the x minus 0, I'm just going to simplify to an x squared. Then the negative negative by the y turns into a plus sign. And then we already did the 4 square root of 3 squared, and that was 48. So it wants us to write an equation of the circle that is shown. Again, I need to pull out my center point, and I also need to find the radius length. So if I zoom in here to example A, notice my center point here is the order pair 4, comma 1. I can find my radius length by counting the little squares horizontally or vertically. So I have a radius right here. Notice each of the squares are going by 1s this time. So this radius right here has a length of 1. Didn't matter if I drew it horizontally or vertically. I still get 1 for the radius length. So now let me go ahead and fill in. So again, I have a radius of 1, and my center point is the order pair 4, 1. Again, remember this is h, this is k, and then I have my r. So we'll fill it in. So x minus 4 squared plus y minus 1 squared equals 1 squared, which is just 1. And I'm done. Let's try the next one. Again, we need to identify the center point. It was labeled in his picture, so it was easy. So this is my center. It's the order pair negative 5, positive 3. Again, I need to figure out the radius length. Just like before, each one of the squares is only 1. So my radius length, I can either count it this way, and you can see that it has a length of 3. I could count it this way. It's got a length of 3, no matter which way I draw it. So now let me go ahead and fill it in. So again, I've got a center, which is located at negative 5, comma 3, h and k. And then I've got my radius length of 3. So it's going to be x minus negative 5 plus y minus 3 equals 3 squared. So this will become x plus 5 squared plus y minus 3 squared equals 9. And you're done. Okay, so now they want us to graph the equation. Now, let's go ahead and we're going to pull out our center and get our radius from the equation. So again, remember in your equation, this is h, this is k. When you pull it out, it's backwards of what you think. So right now, looking at it, it looks like h is -3. But remember, that subtraction sign is part of the formula. So what's coming out here for your center is going to be +3 and -1. Remember, to get the radius, we need to square root this because this is r squared. So my radius is 2. So now I'm going to go ahead and plot the center point, which is the ordered pair, +3, -1. So my center will be right here. And then from there, I'm going to pull out, so the center was at 3, -1 with a radius of 2. So I'm going to count 2 squares to the right, 2 squares up above, 2 squares to the left, and 2 squares below that center point. Then I'm just going to connect all of my purple points. You guys have Notability. It'll make a nice pretty circle. I am not Notability, so I'm going to do my best to make my circle shape. And there is the graph of the circle. The next one, notice this is my H. Notice there's nothing here for the K, so my K is going to be 0. So my center, for example B, is going to be backwards of what I think, so it's -2, 0. Again, you need to square root the 4 to get the radius, and again, it's got a length of 2. So the center I'm graphing is going to be the ordered pair -2, 0, which is going to be located right here. From that center, draw in your radii. Again, 2 to the left, 2 to the right, 2 up above, 2 below. And again, connect them and draw in your circle. All right, so we saw on the previous slide that, again, our equation in standard form for a circle is x minus h squared plus y minus k squared equals r squared. If you wanted to find r, all you would do is square root both sides, and this is how, this cancels, this is how you come up with the formula to find a radius. So it's just the circle equation with a square root on top of it. So what I'm going to do is I'm going to be giving you a point on the circle. So for example, -5, +6. In the formula, this is going to be x and y. Then I'm also going to give you the center of the circle. So for example, -1, +3. Remember, in the formula, this will be h and k. What I now need to do is take these 4 numbers and plug them in to the formula. So I'm going to be placing -5 right here. I'm going to be replacing 6 right here. -1 is going to go right here. And then lastly, let me get another color, +3 will go right here. So let's replace it to get the radius length. Then I'm going to get that radius and the center and then write the equation of the circle. So first thing we're going to do is take our radius formula. I'll go ahead and write it again. And let's plug in the numbers and fill it in. So r is going to be equal to -5 minus is part of the formula, and then the h that's going in here is a -1. And then that whole thing is squared, plus, I'm going to fill in the y, which is 6, minus the k, which is 3.
That's only a point on the circle?
It's a point on the circle. You're going to be given one. And this is all under the square root. So now let me simplify what's under the square root. I end up getting -5 plus 1 here, and then square it. So this will become -4 squared plus 3 squared, all under the radical still. And then I'm left with r equals 16 plus 9. 16 plus 9 is 25. Square root it, and your radius is 5. Now we're going to go back, and we're going to grab our center point, and now we're going to fill it in and write the equation of the circle. So again, remember your equation of the circle, x minus h squared plus y minus k squared equals r squared. Again, remember this is h, this is k, and then your radius is going to go here, and then h will go here, and k will go here. So now the standard form is going to be x minus, and again, your h is a -1, plus y minus the k equals 5 squared. So let me fix the negative. It becomes x plus 1 squared plus y minus 3 squared equals 25. So all of this work will be required when they give you a point on the circle and the center. You will first have to calculate the radius. Once you get the radius, then you go back and put in the radius and the center to get your standard form. Now, technically, you could graph it, and then from there, you could probably, if you're doing it nice and neatly, precisely on a coordinate plane where you've got the little boxes, you could also, once you get that circle on the coordinate plane, again, you can count the squares to get the radius length. But that is it for Chapter 10.